Okay, then I go back and describe this part. Don't want, we skip here. Then I will go back and record this question again. Okay? Then I put it up on the... Okay, so now, using the same idea, they still, because this is still part of the question D, use your graph to find. So what do you think you need to do? So this time is the reverse. You know the Y, then you want to find the X. Still using the graph. No. Using the graph. You cannot use your equation now. If you use your equation, you put in, you can get the answer. But then, because they say, use your graph. So they expect you to go to your graph. This is your graph. Okay? These two curved lines are your graph. So they expect you to use this to show you can get the value of X. Not then.
And then you draw.
Draw from where?
X, Y.
Y equals to?
1.6.
Negative 1.6, right? Okay. Good, Good thinking. So I have to go to Y along the up and down. I go to negative 1.6. Here is negative 1, negative 1.2, negative 1.4, negative 1.6. So this point is negative 1.6. So from here, I go towards my graph. My graph is on the left, right side don't have already. This side don't have any of my graph. So my graph, when my Y equals to negative 1.6, it is, I want to find out this point. What is the X? So I want to read what is this X. I have to draw a straight line towards the X-axis. Okay? Then I read what is the X lor. Negative 1.1, negative 1.2, negative 1.25. If you never read until the middle of the small grid, wrong 1.123 or 1.35. Okay, if you put as negative 1.3, negative 1.4, you never give to the 2 decimal point, most likely you will get it correct also. Should be correct yeah. Don't need to be so exact one. But you must know how to do. You must show that you draw this line. Then it is you are using the graph. Can now, Gabriel? I talk, you also talk. Who listen? Can? Okay. So, when you're answering, because of what you draw there already, here the answer very straightforward. You just say from graph X equals to negative 1.35. Hey, but for your, maybe your graph will read differently from mine. So you draw from your negative 1.6, then you draw, then you see what is yours. Yours may not be the same as mine. Because my graph, this one also I draw freehand. So it may not be so exact also. Okay, so you have to see your own graph. And again, if I want to double check, then I go to my equation and I put the value of Y inside. Y is negative 1.6. Then I rearrange. I don't want my X to be at the denominator. I want to know what is X. So I want the X to be numerator. I multiply X on both sides. It will become negative 1.6. X equals to 2. Then I want to find out what is X. I divide both sides by negative 1.6. Then I press calculator. 2 divided by negative 1.6 is negative 1.25. Okay, so again, mine is not so exact. The most exact answer related by the equations is negative 1.25, but mine is negative 1.35. So it will still get me the marks. Usually there is a buffer one. So negative 1.25, probably they will say plus minus 0.1. So from negative 1.15 to negative 1.35, all will be correct. Okay? Can? So this is the whole idea. Okay. Then we continue. Graph of exponential function. So again, graph is just linking your x value, your y value, and then form a line on the grid. So this one, exponential function are like that one. Your x is at the power, or like that. Okay? When your x is at the power, so far all our x is the bottom. Then we have different power of x. But this time around, when your x is inside the power, we call this a exponential function. Then your graph come out, we call it an exponential graph. Okay? Then there are... Okay. Okay. So your base is always positive and not equals to 1. Okay? So this number can change. It can be 2, it can be 3, it can be 4. When it is 3, it is like that. When it is 5, it is like that. 5 to the power of x. So this A is a number, but it can be different number at different time. Hello, Eunice! Okay or not? Are you feeling okay? Okay? Then you can multiply something. But it doesn't change the shape of the graph. The shape of the graph will always look like this. Here, go up, then go up very, very, very fast. Okay? Because you imagine, even if y equals to 4 to the power of x, when x is 1, it is 4. Y is 4. When x is 2, y is 4 to the power of 2. So y is 16 already. You move by one step, go up 4. You move by another step, it go up to 16 already. Then you move by another step, 4 to the power of 3 is 64. So your y go up very, very fast. That's why you see this one is go up very fast one. When my x increases, my y increases even more. Okay? Then, when my x is no left, no right, my x is 0. What do you all think this value is?
1.
Yes, correct. Because I put my x equal to 0 inside, any number to the power of 0 is always 1. So your exponential graph, when don't have never multiply anything, here is always 1. Okay, good good thinking. Okay, here is always 1. Can? Okay, so we look a bit at the description in case you all are asked to describe about the graph. When the value of x gets very small means very negative. Okay, this one need to do a bit of work. Okay, what they mean is when it goes all the way to the left, what is the value of y? From this graph you can see it goes very close to 0. So y, let me work it out here. When x become very negative, y equals to 4 over x. So if x is a negative number, let's say x is negative 2. Your indices still remember or not? If I want to change my power to a positive number, it will go from my number will go from the numerator to the denominator. Then it will become positive power. Law of indices. Okay, never mind. We will come to this when we do revision. Your power negative, if I want to change the power to positive, it will go from numerator to denominator. Because this one is originally like that. So when it go below, the indices will change from positive to negative or negative to positive. Okay? So when I go very negative, now this one is y equals to 1 over 16. Okay? Then if I go very negative, my y equals to, let's say, 4 to the power of negative 100. then it is actually 1 divided by 4 to the power of 100. Meaning, when I go more and more towards the left, my denominator become a very big number. 1 divided by a very big number, it will go more and more towards 0. It will go closer and closer to 0. That's why my y become closer and closer to 0. As I come here, it goes nearer and nearer the x-axis. Okay, this is y lah. Can? So it will, when the value of x gets very small, the graph gets very close to the x-axis. But it will never touch. Okay? It just gets closer and closer and closer until the end of time, until the infinity. On the other hand, this one you all should be able to answer already. When the value of x gets very large, the graph y gets larger, or very large also. Okay, so as long as you know why if you are asked to describe, can describe in your own words one. When the x gets very large, the y gets even larger, all this. At the y-axis is when your x is equals to 0. At the middle, no left, no right. Okay, no left, no right. If go left is negative, if go right is positive. But at the y-axis, x is equals to 0. So when I substitute x equals to 0 into y equals to 4 over x, y equals to 4 to the power of 0, y is equals to 1. Okay? Then when x equals to 9.5, y is how much? Y and x linked by the equation. So when x equals to 9.5, we just substitute it into the equation. Then after that, key in calculator, 4 to the power of 9.5. Wow, very big number. 524288. So you see, my x only 9.5, haven't reached 10 yet. My y already 500,000 over. So it goes up very fast. Okay? Do you all know how to key in this into your calculator? Y equals to 4 to the power of 9.5. There is this button beside x squared. The x to the power of a box one. You press that one. You press your x. So I press my 4 first. Then I press the x with the square. Then it will let me key in how much power I want. Then I can key in 9.5. Can? All familiar with your calculator? Okay, can? Okay, then let us look at the next part. Question 1. Sketch. Okay, so they want you to roughly know the shape of your graph. Then they tell you this dot here is actually 1, 1. Doesn't mean they want you to pass through the 1, 1. They just put it there as a reference. So that if your graph should go above, you must go above the point. If your graph must go below, you must show that it go below. Okay, so the equation is y equals to 2 to the power of x. My x is inside the power, so I should be thinking, oh, this one is exponential lah. Exponential graph. Then I must be thinking the graph will roughly look like something like going up one. Going up very fast one. Okay, but I need some points. So I need to know the y-intercept. And I want to know when x equals to 1. This one is when x equals to 1, y equals to 1. So I want to know on my graph, when x equals to 1, what is my y? Because like that, then I know whether my graph should be above or below. Okay? Or another way to know is also, if I know my y-intercept is when my x equals to 0, my y is equals to 2 to the power of 0 equals to 1. So actually I know this is 1 already. Okay? Meaning my graph will come, and then when it cuts the y-axis, it is in line with this point. Agree? Because this point is when y equals to 1. So, my graph is going to cut here. And I also know, towards the left, it will go closer and closer to 0. Okay? This is what I also know. It will go closer and closer to 0. So with this few information, I can sketch. So I will be from here. Wow. Why got people so angry one? Okay, so it will go bigger and bigger, then it will cut when y equals to 1, it cuts the y-axis, then after that it will go up. Okay, same so when I told you sketching, turn your book around, just now I also put it upside down so that it fits the movement of my wrist. For those of you who don't want to buy the curved ruler one. Can? Okay, but this time round it is negative. Go! Yeah lah, tomorrow got 4 period, but then you all won't be hard to ask you all to focus for 4 period. Okay? Okay. Quick one the idea, if I don't have this negative, it will be like that. If I have a negative, means reflected downwards okay? So it should be like that. You all go back and think. Can? Or you can use some numbers for yourself to see. Can? Okay, tomorrow we will definitely go into the gradient of graph. Can? If you can read up a bit, then